It is the first sense you use when you are born. 1 out of every 50 of your genes are dedicated to it. It must be important, right? It's your sense of smell. When you breathe, the air molecules would enter your nose and gets filtered first. Almost 90% of your nose working part is occupied by the filters. The small bump region in there is important, which contains the olfactory nerves holding some mucus with them. With this little amount of nerves, you can smell more than 10,000 different odors. Surprising? Yes, it might be, but what more surprising is the working of your smelling senses. It's more complex than you think. There is a lot more physics happening in there, just inside your nose. After the air gets filtered, the molecules get attached to the olfactory nerves and the signals will be sent to your brain and you sense the smell. But the question is, how different molecules gives us the different feeling of smell? Back then, scientists have researched about these nerves, but they are unable to do experiments with the live receptors. Taking the receptors out of the nose would kill its working properties. So, scientists proposed two theories based on how the nose sensory nerves may work. For better understanding, this can be called as a key and lock system. Every molecule has a different structure. This theory says that our nerves would have some locking system. When a particular molecule gets into the nose, it connects a path of only a particular nerve, such that the impulse can reach the brain and we can smell the thing. But this theory doesn't hold good, because we only have 300 different types of receptors, but can sense up to 10,000 types of smells. Which means there's something strange happening inside our nose. Every particle in the universe do vibrate with its own frequency, just like how the different colored lights have different wavelengths and frequencies and thus different energies. This came up with the nose receptors that can sense the jiggly motion and send them to the brain and we smell. Here things get little bit crazier. This process actually happens due to the quantum tunneling. What? Yes. But let's know what is quantum tunneling. It's a phenomena when an electron gets stuck by a little barrier, somehow reaches the other side by creating a tunnel. When two conductors brought together with a barrier between them and applied the voltage, the electrons pushed to the ends. In normal physics, the electron cannot cross the barrier. But when the gap is reduced, the electron makes a quantum tunnel and reach the hole on other side. This can happen only when the hole on the other side is also having the same potential. If the hole has lower potential than the electron, then quantum tunneling is quite not possible. But if we introduced a molecule whose energy requirement is just equal to the energy difference between the charge carriers, then the passing of electron happens by giving the rest of the energy to the molecule to vibrate. Scientists have termed this process as the inelastic electron tunneling spectroscopy. Perhaps this is the process happening with our nose. Perhaps our nose receptors are acting like the metal conductors and the smell molecules are acting as the potential barriers. Next time you smell something, that's probably due to the quantum tunneling. Thank you for watching Scisium. We will meet in the next one.